Hello friends, today we are going to discuss about the application of stacks. So stack is an important data structure which we have built in the previous videos. So stack is a LIFO data structure which has a discipline of last in first out. So we have implemented stack as an array and as a linked list both. So we have seen in the stack that in the array as well as in the linked list, the stack is associated with two primitive operations. That is the push operation and the pop operation. Push operation involves the addition of any element to the stack, and the pop operation involves any deletion of an element or the retrieval of data from the stack. So we have dealt with the stack as a data structure in all sorts of ways, that is in the light of linked list and also in the light of as an array. So now our topic of discussion will be application of stack. In which application field we use the stack data structure. There are numerous application fields in which we apply this stack data structure, out of which I will show you some applications in this tutorial, and this part 1 will consist of one of the many numerous applications of stack. So part 1 will help us to evaluate a postfix expression by the help of the data structure stack. What is a postfix expression? Let me just show you a very simple postfix expression. What is postfix expression? We are going to find the value of a postfix expression by the application of stack in this part 1 video. So what is a postfix expression needs to be explained a little bit. What is a postfix expression? Suppose if we write like this, a plus b, very simple example I am showing you, a plus b, see this in a plus b, this is the operator, the plus is the operator and b is called an operand, a is also an operand. So there are two operands a and b having an operator in between, that is the plus over here. So in this expression is the normal way of writing expressions. So this is the infix expression where the operator comes in between the operands. So this is an infix expression. And what is a postfix expression? Post means after something. So in the postfix expression, this plus will be going to the right side of these two operands. So the postfix expression, equivalent postfix expression for this one will be AB plus. This is the postfix expression. And there is yet another type of expression that is called the prefix expression, and prefix like this, plus will go before A and B. So that will be the prefix expression. So this is the postfix expression, this is the prefix expression, and the infix is a plus b. So this is the infix expression. So this is the concept. This is a simple illustration of the concept of the infix, postfix and prefix expression. Now we will take an input which is a postfix expression and try to evaluate the postfix expression by the application of stack data structure. So our topic of discussion in this part 1 video is the evaluation of a postfix expression by the help of the stack data structure, that is by applying the stack data structure. So the stack data structure finds one of its applications in finding the value of a postfix expression. So let us now get started with an example to show you how that is done. So let me just rub off this portion and write a postfix expression and try to evaluate that. Suppose the postfix expression, I am taking a postfix expression as an example. Suppose this is 7, suppose this is 6, suppose this is 2, suppose this is plus, suppose this is star, then comes suppose 20, then comes 4, then comes a slash, then comes a minus. So this is an expression which is a postfix expression. So our input is nothing but a string consisting of letters, a string consisting of characters, that is consisting of digits, plus, star, slash, minus. So these are the operators. You can easily see that this slash is an operator, this is an operator, star is an operator, plus an operator, but these are definite integer numbers, but these are not numbers in the sense of that we are using it as a part of the string. So each of them can be considered to be a character, but these characters should be considered as integers when we will try to calculate and find the value of the expression which is given in this postfix form. So postfix expression is the input to this algorithm, and we will apply the algorithm. There is a definite algorithm which we will study later on, but in this video I am just going to show you how that algorithm is being applied to find the value of the postfix expression or to evaluate the postfix expression. So in this case, we will see our algorithm goes like this. We will take a table like this, symbol scanned on the left side, and on the right side I will write stack. So I will divide this answer into two parts in a tabular way, having a left side as symbol scanned to be the title of that left side, and the title of the right side will be stack. And there will be multiple steps in which we are, at the end of which we are going to determine the value of the entire expression. So in this case, see, what we have to do is first see this expression from left to right, and see here this expression ends at the minus symbol. After that, we will put a closing brace, we will put a closing parenthesis rather, we will put a closing parenthesis or a right parenthesis on the right hand side of the entire expression, and put it within two double quotes to just signify that this is not the part of the string given originally. So you can consider it to be like single quote as well, because this is a character, it is better to write it in single quote. So we have added this right parenthesis on the right side, rightmost portion of the entire string, which is given in the postfix form. Now, number one step is like this: symbol scanned, and we'll start scanning from left to right. Our scanning will be starting from left to right. So left to right scan. Left to right scan. First, we'll scan this 7, and if you see that there is an operand, then we will push this operand to the stack. Initially, suppose you think that the stack is empty, there is nothing in the stack, and now I will push this 7, because this is an operand, to the stack, and the stack will look like this. Suppose I am writing the stack in this manner, so as to represent this one as the top member of the stack, top element of the stack, and if I go on to add another element to the stack, it will be on the right side, and on the right side you will consider that the top of the stack is on the right side. I am not drawing the stack in an upright manner, I am just drawing it in a horizontal way, and please consider the top of the stack to be the rightmost part of this expression. So this 7 is pushed onto the stack. So stack has one element. Number 2, now we see that 6 is also an operand. So the stack will contain now 7, and before and above 7 there will be 6. So now stack contains 2 elements, and the topmost element is now 6. After that, we see that there is another element which is an operand in the third step. So this will also be pushed to the stack, and the stack will grow in size. The length of the stack will become 3 and this will be the topmost element 2. After that, we see that there is a plus symbol. So, interesting part, we encounter the interesting part over here where we see that an operator is encountered. When an operator is encountered, then our work is to pop the first 2 elements of the stack, pop the first 2 elements of the stack. Suppose this top 2 elements can be named like this. The topmost element can be thought of as A and the next 2 top element can be thought of as B. Now you pop the top element A, then you pop the next 2 top element B and perform an operation B operator A and perform an operation B operator A. So what is B operator A? So this operator is plus. So you perform the B operator A function, operator A operation, and you find that 6 when added to 2 gives you 8. That is 6 plus 2. So plus will be the operator, these 2 will be operands. B operator A, suppose operator is denoted like this, B operator A. So here the operator is plus. So B is what? 6. A is what? 2. So 6 plus 2 means 8. And stack decreases in size. Only 7 remains in the stack because you have taken out 6 and 2. Result is 8 and push this result back to the stack. Push this result back to the stack so that the stack again grows by unity. So now this number 3, this is number 1 step, this is number 2 step, this is number 3 step, and this number 4 step will give us 7 and 8. 7 and 8. Now we see that in the 5th step we encounter this operator star. So we again encounter an operator, not an operand. So our work will be the same as similar as what we have done in the previous step. So what is A here? There is a top element is A and the next to top element B, operator is star. So we will perform the operation like this, 8 B operator A. So we will perform the operation like this, 7 star 8 is equal to 56. So 7 star 8 is equal to 56 and push this result back to the stack. So stack becomes empty out of when we just pop these 2 elements from the stack, and after that stack will again contain 1 element and that will become the topmost element, which is 56. So I will push this 56 back onto the stack. After that, number 6 step, is that we encounter 20. What is 20? 20 is an operand. So we will just push 20 directly onto the stack and the top element of the stack will become 20. After 56, it is 20. On the top of 56, there will be 20. 7. 7th step. What is the 7th step? We encounter 4. 4 will also be pushed to the stack in a similar way. 56, 24. After that, we see that we have encountered a slash symbol, that is an operand. An operand is, when operand is encountered, we again perform that type of operation, that is B operator A. So top element is A, next to top element is B. So B operator A means here the operator, here B is 20, operator is slash and A means 4. So our result will be 20 divided by 4, that is 5. So now I will push this 5 back to the stack and the stack looks like this, 56 followed by 20, 56 followed by 5. 56 followed by 5. So 5 is the top of the stack now. Now we encounter this minus. So there is yet another operand which is to be seen now, that is minus. Now, we will perform a similar operation as we have done in the previous case, as we have done in the previous step. So, this is now A, this 5 is A, 56 is the next to top element, that is 56 is B, and now we will perform the subtraction operation by writing this 56 minus 5, that is B operator A. So, this will give us the value, the result 51. Push the result back to the stack, 51. Now, we see that we encountered the right parenthesis. So, until we encounter this right parenthesis, closing right parenthesis, there is the closing parenthesis rather. So, in that case, if we encounter this, the algorithm is going to be exited. We will exit the algorithm. We will stop our process, entire process, when we encounter this right parenthesis. So, we will just stop or exit from the entire algorithm, and whatever is in the last, whatever is in the stack in the last step, that is in the step 9 in our example, is to be taken as the value of the postfix expression given in the question or given as an input. So, this 51 is nothing but the result of the evaluation of the postfix expression. So, the result is now, suppose you take a variable result and put this and pop this top member of the stack, only one element is there in the stack. You can just pop it and put it on this result, in this result variable, and result variable will contain 51, the stack will become empty. So, we have exited from the algorithm and the result is 51. So, this is our answer to this entire problem. So, this is one of the applications, one of the various applications of the stack data structure in which we have discussed in this video, but in the later videos we are going to discuss some more applications of the stack data structure. So, if you have any doubts or queries relating to this entire application of stack part 1, you can post your doubts and queries into the comment section below so that I can address them. Thanks for watching this video.